this, okay? So we are doing EMG today. That's electromyogram. We're going to measure electrical activity of our muscle cells. We've talked about the skeleton, all the bones. We've talked about the skeletal muscles that attach to those bones. And now we're going to talk about how those muscles work. So we can use an EMG to assess health of muscles and nerves. For example, we should see a constant low-level electrical signal that we call tonus. If you don't see that, there's something wrong with your electrical conduction system. So there might be a nerve issue, it might be a muscle issue. So we can use this, generally speaking, to assess health of muscles and nerves. When we do this, we're measuring action potentials. We're measuring electrical activity. We're not measuring the force output. We're going to use, grab one of these, this device called a grip dynamometer. It's down here on the bottom, dynamo meter. Notice as I squeeze it, you have a dial that increases as I squeeze harder. So squeeze a little bit, squeeze harder, squeeze hardest, it goes up. It has pounds and kilograms. We're going to use pounds. So whenever you're looking at your report that you have to fill out, you see force output, it's always pertaining to this. You're going to hear me talk about target forces. That's regarding where the dial goes to on this, how hard you squeeze. Target forces, but yeah, it is target output as well, same thing. So for example, everyone's going to squeeze 20 pounds of pressure so that we can compare the electrical activity between everyone at 20 pounds of pressure, force output. So how all this works, keep in mind that our brain and our spinal cord are continuous, and they make up the central nervous system. So they're sending electrical signals through our body, through motor neurons, to our skeletal muscles, and then we're going to pick those signals up using electrodes and then collect that data on the Biopac. That's what we're doing today. I mentioned tonus. If you don't have that continuous low-level signal, your muscles will start to wear away, and we call that atrophy. If they go for too long in an atrophied state, they can actually turn to connective tissue. So this motor unit contains a motor neuron and the muscles that it innervates. So innervate is the verb, meaning nerves run through something. All right. So this is a figure to show you what an action potential is. You're going to see words depolarize and repolarize. So who knows what polar means? Just generally, broadly speaking, what does polar mean? So it means that one side is different from another side. There's a difference, right? Opposing. So here in this case, we're starting out negative, and then to depolarize, we're going to cross that zero line. Okay? So we are depolarizing, and then we go through a state of repolarization. You don't need to worry about these molecular mechanisms of how this works. I just wanted to introduce depolarization and repolarization. Notice this dotted red line here that says threshold, and action potential is all or nothing. You're going to get a stimulus until you reach a threshold. If you do, that action potential fires. If you don't reach threshold, you don't get that action potential firing. It happens or it doesn't. Okay? This is what it's going to look like in real time. So threshold, depolarize, repolarize. This could be a hyper-repolarization and then coming back to resting. But right after the action potential, there's this little pause that we're going to say is a latent period before the muscle actually contracts. So you have the action potential firing. Once it hits a threshold, slight delay, and then the muscle contraction. So this is in your Biopac to show you just that. So like I said, we are going to use electrodes. You have them on your Biopacs. We're going to place 3 on each arm, just like in this figure. So we're going to have 1 up here and then 2 down at the wrist. And so we're going to measure not inside of our muscle cells, because I'm not about to probe y'all with needles, right? So we have sticky electrodes on the outside of our skin, and they're going to measure electrical conductivity as they move from one electrode to another. So this is also in your Biopac. It's a little bit confusing, so just follow me here. So in time A, we're going this direction. This is inside the cell and outside the cell. Inside the cell, we have this negative charge, outside, positive charge. Electrode 1, electrode 2. So we're going to say electrode 1, electrode 2. Okay? So moving that direction. Our measurement on the Biopac is going to subtract E2 from E1. If both environments are the same, it cancels out, we get 0. Because there's no difference at this point and at that point between the white or down at the wrist. But in time B, now we have negative at E1 and we have positive at E2. So now we have a negative minus a positive, we get a negative number. So then as that signal moves this way, so now we have our negative signal moving this direction. It was here, now it's at E2, but E1 has come back to resting. Again, remember we're measuring on top, not inside the cells. Now we have E1 minus E2, so that's a positive minus a negative. The negatives cancel out. You get a positive number. So 1 minus negative 1 is really 1 plus 1. Right? Everybody on board there? That's what's going on right here. So this is what you're going to see. A, B, and C. You get a negative, you get a positive, you get a negative, you get a positive as your signal moves from one electrode to another. So this is what it looks like in the intracellular and extracellular. This is what we're actually measuring because it's all outside the cells. Is anyone totally lost right now? Okay, what are you confused about?
It's just going over my head right now.
Okay, so this right here shows you that there's a difference if we were to measure inside of our actual cells, the electrical activity that they receive from neurons. It would look like this. But we're not doing that. We're going to place electrodes on top of our skin. So the conductivity is different. The signal that we pick up is different outside the cell versus inside the cell. We're following a signal moving from one electrode to another, right? We don't measure from here. We're not measuring on our heart. We're measuring a signal as it goes from this electrode to that electrode. And then, yeah, question.
Sorry, so we're measuring by different times or like based on the number we get, we determine whether it's time A, B, or C. Does that make sense? I'm confused about like the times, like
Sure.
that part of it. I'm not confused about the intracellular versus extracellular.
Okay.
This is what I'm confused about.
Gotcha. So the Biopac makes this calculation right here.
Okay.
The reason that I put this stuff in here is so that you can understand why we get negative and why we get positive values.
That makes more sense.
Okay? Because you're going to see raw data that does this. Then we're going to use integrated data that's all positive. But why we have negative and why we have positive values is because of this. Because the signal moves from one electrode to another. And it's picked up differently as the signal moves. Okay? So this is what you're going to see on your screens. Let's go ahead and open this up. The way we're going to do this is so we have our Biopac. Everybody see this on your screens right now? The third dot, it says open a graph file. All right, so for me, I'm going to click this. So now you should see sample data in there. Let's see. You're going to go to saved data file. So it's the lowest box. On the left, there's a dot to click. Do you all see that? No? Alright, so then go sample lesson data. Yours might be a little bit different. Yep, sample lesson data, and then go to the very top one. Go to Gale L01 and click OK. You you should get this. Yeah. That's good. Okay, so we're going to drag that text box down. If you go to the top of it, pull it down. So right now we're not concerned with the text down here, so we can go ahead and drag that down. We won't look at the data. Yep, perfect. All right. You good? You all good? Yeah. Okay. So right now, see, I have this pointer. You want to find the cursor. So for you all, it's going to be up here in this top left region. For me, it's right here. So find the cursor. Should be right below edit, I think, in the top left. Yeah, okay, so you click that. That's the tool you use to highlight. So now, if you go up here in your data, you can click and drag and highlight certain areas. That's what that cursor tool does. All right, perfect. So that's how you're going to analyze your data after you collect it in today's exercise. So we're going to squeeze our dynamometer. We're going to get data that looks similar to this. Then you're going to highlight it to record it in your tables. So the tools we're going to use, up here you see these channels. We have channel 1 and channel 40. Channel 1 is our raw data. That's where we get that positive and negative value. So it's shown up here in red. So notice this is 0. We get positive and negative values because of what we just talked about. This is integrated in millivolts per second, and it's an absolute value recording. Everything is above 0. This is channel 40. Channel 1 is on the top. Notice 1 says EMG. Channel 40, integrated EMG. Right? So what we're going to do is we're going to set up channel 1 with peak to peak. It says P-P. So go up here and select channel 1, and then you get a string of options next to it, and go P-P. So the box right next to, yeah, so where it's highlighted in the purple box, you want to click that and go channel 1. And then the one next to it where it says mean, make that say P-P. All right, you all good? Yep. Good? Okay. The next box we're going to set up is channel 40, and we're going to use mean. So notice I have channel 1 peak to peak, and then an equal sign, and I have a value. And then I have channel 40, mean, and then I have another value next to that. Those are the only two values that we're concerned with today. So 1 peak to peak, and then 40 mean. Okay, so now, what peak to peak does is that takes a maximum and a minimum point. For example, if I highlight this region here, so I have this grip highlight from this line to this line. Notice my peak to peak is 2.824. If I extend this out further to my tonus regions between the squeezing, it doesn't affect my peak to peak because there's no value in this region or in this region that is higher or lower than what I had already selected. Does that make sense? If you're looking for a highest and a lowest value and you highlight more values that are less than that, notice again I can go all the way out here and my value doesn't change. But if I go and select the one that is higher, it does change. Then I can continue just highlighting all the way over and it doesn't change because that is my highest value and that is my lowest value. Everybody good there? That's what peak to peak does. The mean takes an average in channel 40. It's always going to be positive because we don't have any negative values down here. So, in your Biopac, you're asked, why do we not take the mean of channel 1? Who wants to take a guess? So, let's just think about, like, take a step back. If you have positive and negative values, why would you not want to take the mean necessarily? They cancel out. Is pretty much it. So if you have all of these values and then all of these values, we can even do this. So we take channel 1 and go to the mean, and we don't get anything that really helps us. Okay. Similarly, we're not going to take peak to peak of channel 40 because it's all absolute values. It doesn't give us useful information. We want the mean. It's already integrated in time. So that's what we're doing today. You need to know how to highlight, set up your channels, and then collect your data. So your data in your tables will come from these boxes. If you wanted to know time, you can choose any channel, channel 1 or channel 40. I'll go ahead and show you that. So if I do delta t, that is change in time. Notice my delta t is the same for channel 1 as it is for channel 40 because they're happening at the same time. We're recording them at the same time. So delta t, if I had 1,000 channels, it's always the same for every channel because highlighting that does not change this box between channels. Everybody good there? That's going to come up later in the semester. Okay, so that's Biopac. I have just a couple more things for you. Questions about that? No? So that's the majority of what you're doing. And then I have a YouTube link right here. This is what you're going to see. If I can get this to play, that'd be awesome. I don't want to go back. All right, so as you squeeze, you're going to see your data become more intense as you squeeze harder. So this person is squeezing his fist harder and harder with every time, and notice the raw and the integrated data get larger with more force output. So we aren't squeezing our fist, we're going to use the grip dynamometer, but you're going to see that happen as you work through your Biopac today. Cool. All right. So, things that affect the measurements that we get in the Biopacs will be how many muscles are recruited, how many muscle cells are recruited, and then how often, or the frequency of the recruitment. The size of the muscle cells, it's not going to directly affect the electrical activity, but if you have larger muscle cells, you probably don't need as much recruitment in terms of the amount of muscle cells recruited because your muscle cells are larger. Does that make sense? If you have a lot of subcutaneous fat, so fat below the surface, that can act as an insulator and prevent the electrical signal from reaching the electrode as well as it could. Think about trying to use a stethoscope to measure your heart rate if you're wearing 5 jackets. Kind of hard to pick that noise up if you have big blankets in between. Also, if your electrodes aren't in the right position or if they aren't stuck properly, if they're moving around, right, then you're just not going to get good signals because our signals are our antenna, if you want to put it that way. We talked about this, but I have it right here just so that you can have it for your own benefit. We discussed it already. We talked about this already too. Okay, so in terms of calculations, you need to know 2 types of calculations for today. I'll wet my throat. You have a percent of equation. So that's going to be the part over the whole times 100. That's the equation that she gives you, but I don't really like that so much because you can be asked to put a whole over a part, and that can still be a percent of. So the way that I do this is I do is over of times 100. So what I mean by is over of, for example, what is the percentage difference of final weight? So we have an is and we have an of. So those are relative terms. So I do is over of times 100, my little thing, because they're often in that format. Another is the percent difference from, so how does she say it? Value minus reference over reference times 100. You might be more familiar with observed minus expected over expected times 100. So either way, keep in mind that you have one value minus another value, and then it's over that other value. So here I have O minus E over E. If you did V minus R over R, you have the same value going that way. So that's one way that I remember to keep these terms straight in this equation, is that it always tilts back that way. Multiply by 100 to get your percent. You can download the software at home. I highly recommend that. If you have a flash drive, you want to save your data today, you can take it home and work through all this at home instead of having to come into Open Lab and use these computers. So like what I showed you, how I was doing it, I just got this for free. Some of my students had trouble downloading it though, so if you want, I can give you my copy, or you can extract it from these computers if you don't want to go online and have to take it. So you can have the software at home. What we're doing, we're going to choose target forces. So we're going to have our dynamometer. Just for fun, I recommend seeing what your max is in your left and your right so that you can choose appropriate target forces. So let's say I squeeze and I get 50 for my max in left. I'm going to choose my target forces as maybe 10, 20, 30, 40, right? Because I don't want to choose a target that's above my max or right at my max, because we want to get a max, yeah? So your max will be different between your dominant and your non-dominant arm, most likely, even if it's just slightly. So we're going to choose our target forces appropriately, but you must have 20 pounds. And I have a table up here behind the projector, and we're going to record our data in, I think it's like table C, table B in your handout. So cross-group comparison. We're going to have 3 electrodes per arm, so you have 6 at your stations. You're going to turn on your Biopac. There's a switch in the back left. You'll see a green light come on. You're going to open up the software, and we're doing L01. So whenever you all first open the program and it took you to that blank screen, you chose record new data, L01, EMG1. We're doing that, okay? But that sample data, you can just practice with it at home. So for the next Biopacs, you can do practice work before you even come in and do the exercise. So I think that's kind of cool. It's going to ask you to calibrate the machine, follow the instructions. I believe it asks you to just squeeze for a handful of seconds and then release for a few seconds. You'll see a box in the bottom. It should look similar to that box. If it doesn't, recalibrate. So here's what we're doing, and this is really important. We're going to start with our dominant arm. If you start with your non-dominant, it's not the end of the world. We're going to take 10 recordings and then push suspend, okay, or move on. So we're going to take first target force. We're going to squeeze it for a few seconds. We're going to rest for about 4 or 5 seconds. Then you're going to take your second. So 10, rest. 20, rest. 30, rest. 40, rest. And then squeeze the shit out of it, max. Then you're going to go back and redo all that with the same arm. So 1, 2, 3, 4, max. 1, 2, 3, 4, max. Suspend. So we're going to take 2 recordings per target force per arm. You switch, do the same thing for your other, well, I say arm, that should say limb, right? Because what's an arm? Humerus, right? So my mistake. Then you're going to do what I showed you how to do. You're going to collect data from channel 1 and from channel 40. Fill out your tables, and that's it. Questions?